Hey guys, this is Mr. C, and today I'm going to be showing you how to prove the Pythagorean Theorem. This method of proof is one of my favorites, and there are many different ways to prove the Pythagorean Theorem. Actually, a lot of famous people have come up with proofs, like James Garfield, who was President of the United States. And this is one of my favorites because it's real easy for students to understand at the Algebra 1 level. So what I did was I drew a square right here, and then inside the square I created another square by taking the same length, which I call A, here, 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 and here. And then I called the other length right here B. And if you notice, we have 1, 2, 3, 4 triangles, and they're all right triangles because a square has 4 right angles. So this whole proof is built upon the fact that you have right triangles here at the very beginning, and that's really the fact that we need, other than that when you do that, take this A and this B right here for these two sides of this triangle, by hypotenuse, all 4 of these is going to create a square inside the big square. And that's another thing that's pretty easily proven. But here's how this is going to work. So what I'm going to do is I'm going to deal with the area of this big square. And I'm going to deal with the area of that square in 2 different ways. Well, first of all, this square on the outside has a side of length A plus B and another side of A plus B. If I want to know the area of this square on the outside, it would be A plus B times another A plus B, right? So that's going to give me the area of the square. Well, if I expand that out, A times A is A squared, A times B is AB, A times B again is AB, and B times B is B squared. These 2 terms right here can be combined, and now I have A squared plus 2AB plus B squared. So that is one way to find the area of this big square. However, you can also think of this big square as a bunch of pieces, like a puzzle. I have 4 right triangles and a square in the middle. And so if I take each of these pieces here, I have 4 triangles, right? 4 triangles, and each of those triangles is 1/2 base times height. And so if I think about it that way, I have 4 of them, and each of them is worth 1/2 base B times height A, which I'm just going to call AB, plus the area of the square in the middle, which is just going to be C times C, which is C squared. Now, if I simplify this a little bit, 4 times 1/2 would just be 2, right? So that's actually equal to 2AB plus C squared. Now, I did that 2 different ways, but even though I did it 2 different ways to find the area of this big square, both of those ways should be equal, right? Because it's the same square. So now what I do is I set this guy equal to this one. So I say A squared plus 2AB plus B squared equals this, 2AB plus C squared. Now, if both of these are equal, they both have a 2AB right here. So if I subtract 2AB on both sides, these cancel, and I have A squared plus B squared equals C squared. Okay. Now, this right here is a relation I can use now, or an equation I can use for any of these right triangles right here. A squared plus B squared is equal to C squared, because the whole thing was built upon the fact that these were right triangles, and that's all I really needed to know. So now I can use this for any right triangle right here, because the values of A and B here were just arbitrary, right? They could have been really anything as long as it made a right triangle. So for a right triangle, we can now officially use the fact that A squared plus B squared is equal to C squared, and that is a proof of the Pythagorean Theorem. Hope you guys enjoyed this, and remember to like and share, and we will see you guys later. Bye.